All right, so we're here to do a video on correlations. Teenage sex leads to bad moods in later life. Now, this was a title that was in a newspaper. And basically, what we're doing here is looking or evaluating the evaluating media as we look at correlational data. Now, not only was this correlational data where they compared the people or the animals, actually. This was done on hamsters. So the media headline says teenage sex leads to bad moods later in life. So it has a causal effect. It's saying that teenage sex causes bad moods in later life. Well, all they did was actually have hamsters who had sex before they reached full adulthood, and then they put them in water, and they noticed the ones that swam, did not want to swim as much because they're natural swimmers and they enjoy swimming, had anxiety, or different activities that had anxiety. And then they eventually led to this headline. And so one of the things with correlational data is that it is a relationship. So they found a relationship between these hamsters that had sex early in their life and have behaviors that showed anxiety and depression. Again, it's hamsters, so they don't exactly know, and they don't know if the sex caused the depression or if these, or what the hamsters actually, or there was other causes. And so they could only just draw a relationship between these possible bad moods and the sex that they had earlier on. But we don't know exactly if that's what caused it or not. And obviously this headline that says teenage sex leads to bad moods is awfully misleading given that it was teenage hamsters. So, what kind of research was this? What is the defining difference between a correlational study and an experiment? A correlational study is only trying to find a relationship between two variables, where an experiment is trying to find a cause and effect relationship between the variables. So in a correlational study, you don't have an independent and dependent variable like you have in an experiment. You just have two variables, and you're looking for a relationship between the two. So correlational studies. What are they used for? They're to show links between two variables. There are some things that can't be studied in a cause and effect manner, meaning that we can't necessarily look at why certain brains develop certain ways. We can't put kids in a deprived environment and see how they turn out. And so there's just things where we can look for relationships. We can look at kids that watch violent TV and whether they have aggression on the playground. We can draw a relationship between the aggression in the playground and the TV, but we can't necessarily say that one goes with the other. Useful for detecting patterns that may suggest a new hypothesis for experimental testing. And they're also useful when it's unethical to try and bring a cause and effect. Does smoking cause cancer? We can't take 50 teenagers and say, okay, you're going to smoke for 20 years and then we're going to check your cancer rates. Obviously, you can't do that, but what you can do is look at people who smoke and look at their cancer rates. But you could only draw a correlational relationship because there's so many other variables that you can't isolate. What do they not do? They do not imply causation, despite the fact that a lot of times when media portrays them, it shows some type of causation. Are quantitative in nature. They are all about numerical data. Sometimes you're just looking at two data sets and seeing if there's a relationship between the two data sets. Other times you're creating the data and then looking at how they compare. But they only show a relationship between two things, two variables. When one variable changes, the other changes as well. Either positively in the same direction on the x and y axis, or negative in opposite directions, where one goes up, the other one goes down. So here is an example of a correlational study. Grade is on the left-hand side here, when you're looking at it, the hours are on the bottom. And so the X and Y axis. And so you've got grades going up, and the hours of study go up. And when they go up together, this creates a what type of correlation? A positive correlation. And this number right here is the correlation coefficient. And the closer it gets to 1, the closer you have a perfect correlation between two variables. Perfect positive correlation. The closer it gets to -1, the closer you have a pure negative correlation. And the closer it is to 0, the less there means that there's very little or no correlation whatsoever. This is where mathematics will cross over to psychology. And so these scatter plots are something that you can use to look for correlation. You can also compute the correlation coefficient. So this is a negative correlation. Your grade and the amount of adult beverages you have. And you see the negative number, 0.74 is a pretty strong correlation. The closer it gets to 1, the stronger it is. Okay, so correlational data. Make scatter plots of the following two charts. And then you can look for the correlation coefficient. What is the correlation of this data? So at this point, what I want you to do is go ahead and stop the video, plot this out, and then you could take a look at what I plotted out on the PowerPoint, and you could see how close you are. Just decide whether it's a positive or negative correlation. Well, now that you've gone ahead, either you've done it or you haven't, but either way, you see that there is a positive correlation going up between the years of education and the amount of money you make. So this is the years of education, this is the amount of money you make, and this is mislabeled. And so these are the combination of where you're at. Okay. Task, analyzing the headlines, correlation or causation. So what I want you to do here is when I put the headline up, you're going to tell me whether you think it is correlation or causation, or you're just going to write it down on your paper. Sexual lyrics prompt teens to have sex. Listening to sexual lyrics is associated with teen sex. Memory retention enhanced by sleep. People who sleep more remember more. Kids' brains who take music lessons have bigger brains. Music lessons improve kids' brain development. As you can see in A and B, sexual lyrics prompt teens to have sex versus listening to is associated with teen sex. So this is the causal, this is the correlational. And here, memory retention enhanced by sleep is the correlation because it's just showing a relationship between memory retention and sleep, whereas people who sleep more remember more, and that is showing a causal effect. Kids who make music lessons have bigger brains. Cause and effect. Music lessons improve kids' brain development. Okay, and that's debated actually. There's some new studies from Harvard that actually disagree with this whole music and brain development. But hey, it can't hurt to play music. Daytime TV tied to poor mental scores in the elderly. Correlation, causation. Church attendance boosts immunity. Child anxiety linked to drug use. Political bias affects brain activity. Breakfast helps girls stay slim. And low self-esteem shrinks the brain. Eat sweets, live longer. And disciplinarian parents have fat kids. Okay? Most of these, if it says effects or tied to or linked, we're looking at correlation. If it is a statement that just says low self-esteem shrinks brain, eat sweets, live longer, disciplinarian have fat kids, we're looking at causation. Problems with correlational research. Number one, directionality problem. What causes what? Let's look at an example here. Where is my example here? Okay, so we're going to go back here and I'll just give you the example. I thought it was going to be here. What does this mean? So directionality problem, what causes what? One of the things that people have looked at in the past is looking at how much does the amount of TV you watch affect your grades. And so basically, is it people who have high grades are studying more so they don't watch as much TV? Or is it because you don't watch much TV, you're able to study more so you can have better grades? Or is it that people that aren't smart watch TV and don't get good grades? And so what is it that causes the link between a lot of hours watching TV or consuming media and your grades? So what does this mean? Basically, what causes what? Textbook example is the number of hours of television viewing increased, so did the level of aggression in the child. What caused what? Was it because aggressive children like aggressive television? Or is it because the television causes the aggression in the child? Or is it because the parents who are aggressive and teach it to their children also allow them to watch hours of violent television? What caused what? New around these parts, stranger, and yet the question remained, who came first? I think it's funny. But again, it brings up this idea of bidirectional ambiguity. What causes what? Did the chicken or the egg come first? Okay, example, bidirectional ambiguity. Okay, so an example of bidirectional ambiguity. TV watching is linked with childhood obesity. The degree of obesity rises 2% for each hour of TV viewed per week by those aged 12 to 17. Why? Less exercise, more snacking, classical conditioning, food and commercials, so that you are then drawn to that food, or obesity leads to more TV watching because you're tired and you don't feel like getting up and moving. Or it could be other causes, as in the parents model eating or don't have good eating habits, or there's a ton of junk food around and people eat and then they watch TV. So there's lots of different causes here. Okay, third variable issue. Milk consumption is correlated with increased rate of cancer. Okay, how does that work? Well, people who drink milk over a long period of time, from when they were early on in age, and older people tend to get cancer. So milk consumption is correlated with an increased rate of cancer because the older you are, the more milk you have consumed, and the higher rate you have of cancer. People in more affluent cultures, more milk, live longer, therefore likely to get cancer. Quality of daycare is correlated with child abuse. Better supervision of children results in more consistent reporting of incidents. So yes, quality of daycare is correlated with child abuse. Child abuse raises with the good quality daycare. Well, why? Because there's better supervision. So we're getting more consistent reporting of incidents versus poor daycare, which doesn't really report the incidents. So in each of these cases, we can see how the third variable is the issue and not because it just doesn't make sense that these two would be correlated. All right, identify sampling techniques and strengths of weaknesses of each method. We'll do that later. And so we are done with correlational behaviors. And this is the video as far as correlational data and correlational issues. You can get some ideas of what the strengths and weaknesses of correlational data are, correlational studies. And we will use correlational studies quite a bit in biological, as it's hard to show direct links because you have to mess with people's brains. And so that's not ethical, so therefore we will do a lot of correlational data when we move forward. And you always have to remember with correlational data, it just shows relationship, does not show cause and effect. All right, thank you for watching this, and we will talk tomorrow.